Hello everyone, we are back again with part 5 of the video related to the concept light reflection and refraction. In part 4 we have discussed about the rules for formation of images by concave mirror. Today we'll be talking about how to draw the ray diagram. So basically we'll talk about formation of images by concave mirror. So just to inform you, when we talk about formation of images by concave mirror, there are basically 6 cases you can see on the screen. The 6 cases are when the object is placed at infinity, when the object is placed beyond C, when the object is at C, when it is between C and F, when it is at F, and when the object is between P and F. So whenever we want to draw the ray diagram, first thing we need to do is draw a concave mirror, draw pole. From pole, take a distance of let's say 3 centimeter and label focus. From pole to focus, the distance would be 3 centimeter. Similarly, from focus, take a measurement of 3 centimeter and mark center of curvature. So now from this, we understand that distance from pole to focus is 3 centimeter and distance from pole to center of curvature is 6 centimeters. So if these distances are taken care of, then your ray diagram will be accurate and you'll get the required result. So let's begin with the ray diagram. Case 1. When the object is placed between focus and pole. So as I told you, first thing you need to do is draw concave mirror, and let's keep the object. So object is between focus and pole. So we can keep object anywhere between focus and pole. The moment we are keeping the object, we have to use any two rule. If you recollect from our previous video, rules for formation of images. So we will be using the two rules. Rule 1, when the ray is parallel to principal axis, what happened? And rule 3, which is if the ray passes straight through the center of curvature, what happens? So let's see, we'll use rule 1, which goes like this. If a ray is parallel to the principal axis, then after reflection from the concave mirror, it bounces back and it passes through focus. So this is rule 1. You can see, I'll show you again. When the object is kept between pole and focus, rule 1, a ray which is parallel to principal axis after reflection passes through focus. We will use rule 3. Now whenever we have to draw ray diagram, we have to use any two rules. So as I have told you in the previous video also, that we will prefer rule 1 and rule 3 for majority of the ray diagram. Let's see what happened when we use rule 3. So rule 3, when a ray is passing straight through a center of curvature, we observe that it reflects back in the same direction. So this becomes rule 3. Now if you observe the ray diagram, here the rays are diverging, which means they are going away, and as we go far away from the mirror, we observe that they are going to go far off, which means there is no chance that they will meet anywhere here. It means we have to go backward. So if we are going backward, it means we are going in the virtual region, and then we will have to draw the rays backward. Dotted rays means they are not real, they are virtual rays, and the region is virtual. So you can see when I draw the dotted rays, when I take these rays backward, they are crossing somewhere, and that point where they are crossing is the point where we will obtain the image. So you can see here, this is case 1, when the object is placed between focus and pole of concave mirror. We obtain the image which is behind the mirror. So whenever we say image is behind the mirror, it means it's a virtual image. And when we say it's a virtual image, by default we know virtual images are erect. So now we have to write the conclusion. So when we write the conclusion, there are 3 conclusions. One is about the position. So where is the object? Where is the image obtained? The image is obtained behind the mirror, which means it's virtual and it's erect also. So what are the conclusions? Let's have a look at them. So these are the conclusion. In this case, the image formed is behind the mirror. We have seen this. Enlarged, you can see the size is magnified here. The object was AB and the image formed is A dash B dash, which is having magnification greater than the object, and we can see it's behind the mirror, so it's a virtual and erect image. So this is your case 1. If you want to draw it in exam, this is what you should be drawing it, and you'll get full marks for that. Many a time it happened that students just draw the ray diagram and they don't write the conclusion. So there are marks for conclusion also. Without the conclusion that they write, the ray diagram is incomplete. So please do not forget to write the conclusion also. So case 1, when the object is placed between pole and focus, the results are image obtained is behind the mirror, it is enlarged, it is virtual and erect. So take some time to grasp this concept. In the meantime, we'll go to case 2. When we talk about case 2, when the object is placed at focus. Again, as I told you, first thing you need to do is draw basics, draw concave mirror, pole, principal axis, do the proper measurements of pole to focus and focus to center of curvature. We'll keep the object as focus. You can see object is kept at focus. We will use two rules again. Rule 1, a ray which is parallel to the principal axis after reflection passes through focus. Rule 3, a ray which is passing towards the center of curvature after reflection passes as it is, and you can see this time the chances of these rays meeting are again nowhere there because they are parallel, and in the virtual region also they'll be going parallel. So it means somewhere at infinity, parallel rays, we can say somewhere at infinity they will meet, and that's why in this case we say that the image will be real. And if it is real, the results are going to be like this. So when the object is placed at focus, you can see these are the results. Image is obtained at infinity. As it is at infinity, from the principal axis, we don't know where it will meet. So it is going to be highly enlarged. And because it is in the real region, so the image formed is real and inverted. So this is case 2. And usually students also forget to draw the arrows. This is very important that we draw the arrow. Without the arrow, the ray diagram is incomplete. Going ahead with case 3. So now case 3, we are going away from the mirror. So case 3 is going to be object between focus and center of curvature. So again, draw the basics. First thing you need to do is draw basics, draw pole, draw the principal axis. Now we are going to keep the object anywhere between C and F. When we say between C and F, it could be near F also, it could be near C also, based on how you're drawing it. So let's keep the object between C and F. So when we keep the object between C and F, again we will be using two rules. This time we will be using some different rule, but we can also use the previous rule that parallel and passes through focus. So what we'll be doing here on the screen is, you can see we are using one other rules. Rule 1 we are using is a ray which is parallel to the principal axis after reflection passes through focus. And this time we are using rule 2, that a ray which is passing through focus after reflection passes parallel to the principal axis. So whether you draw with rule 1 and rule 3, rule 1 or rule 2, any two rule, you will get the correct results. And you can see the rays are meeting somewhere here. And now this is the real region, which means the image in this case formed is real and inverted because it is below the principal axis. So let's have a conclusion of this case. So you can see the image is formed. Now image formed is basically, if you'll observe, is magnified. The previous case we have got highly magnified image. This case we are getting the image which is magnified. So if you observe, the distance from the mirror is increasing, whereas the size of image is decreasing from the second case onwards. So let's see the conclusion. The conclusions are, you can see when the object is placed between C and F, you can see the image is formed beyond C. It's formed beyond center of curvature. It is enlarged. You can see it's larger than the object, and it is real and inverted. What I showed you was rule 1 and rule 2 here. And this image, you can see rule 1 and rule 3 are used, as we have discussed in the first case also. So this was case 3. Take some time to grasp it, and we'll go for case 4. So as we discussed, case 3 was between C and F. So case 4, yes, you have guessed it correctly. Now we are going away from the mirror. So next position is center of curvature. So case 4 is when the object is kept at center of curvature. So let's see, when we are keeping the object at center of curvature, again, now this time we can't use rule 3. So we'll use rule 1 and rule 2. So rule 1 is, first thing you need to do is, but obviously draw concave mirror, basics basically, draw concave mirror, label pole, draw the principal axis, measurement of P to F should be equal to F to C, then only you will get the correct result, otherwise you won't get the results. Going ahead, let's use rule 1. A ray which is parallel to principal axis after reflection passes through focus. And we'll use rule 2, a ray which is passing through focus after reflection passes parallel, and you can see the rays are crossing exactly at the place where we have kept the object, which means in this case the image is formed which is inverted but at the similar position as where the object was kept. So in this case the results are going to be image formed is real and inverted at C, and you can see the size remains same. So these are the conclusion for case 4 when the object is placed at C. In this case, the image formed is at C, which is center of curvature. The size of image remains same and the nature is real and inverted. So whenever you are drawing the ray diagram, these three conclusions should be there. Where is the image formed? What is the size of image and what is the nature of image? Now, after this, you have guessed it correctly. Now, the next case is going to be when the object is placed beyond center of curvature. So let's try it out. When the object is kept beyond center of curvature, when we say beyond, it means anywhere after C is valid. So let's see it. I'm keeping the object here beyond center of curvature. So we'll use rule 1, a ray which is passing through a ray which passes parallel to the principal axis after reflection passes through focus. And rule 3, a ray which is passing through center of curvature reflects back as it is. So in this case, you can see the rays are crossing between C and F. So the image is going to be real and inverted. And based on the size, let's see what is going to be the size. You can see in this case, the image formed is smaller than the object and it is between F and C. So what are the conclusion for case 5? If the question says draw ray diagram for concave mirror when the object is placed beyond C, this is your ray diagram. The results are when the object is placed at the position beyond C, the results are image is obtained between F and C, which is focus and center of curvature. Its size is diminished, smaller than the object, and it is, you can see it's in the real region, so it is real and inverted. Now, after this, going ahead with the last case, you have guessed it correctly. We started with case 1, which was between P and F. Then we started with F, between F and C, then at C, then beyond C, and now we are going far away from the mirror, which means the last case is when the object is kept at infinity. Now, in this case, we'll draw the basics and we will keep the object at infinity. Now, when we draw the object at infinity, we don't know where the object is kept and what is the size. So we just draw the parallel rays. And when we draw the parallel rays, we know the diagram of convergence can come up. We'll use rule 1 only in this case, a ray which is parallel after reflection passes through focus, and below the principal axis also it's the same situation. So in this case, image is formed. You can see all the rays are crossing at F. It means the image is formed at focus and it's going to be highly diminished. You can see case 6 when the object is at infinity, image formed is at focus F, highly diminished, which means point size image, and real and inverted because it's in the real region. Now, if you'll see your textbook, the cases are given in the reverse order, but what we have discussed are from start to infinity. It's always good to go from start 0 to infinity rather than from going from infinity to 0. So you can see these are the 6 situations. So if you observe out of these 6 situations, leaving this part, when we say between P and F, this is the only situation when we get the image by concave mirror, which is virtual. Now, virtual and erect, and the size is enlarged. When we talk about the other situations, you can see all the other cases here as we are going away from the mirror. So in this case, as per your textbook, as we are coming towards the mirror, you can see the image is going away from the mirror. So when the object is at infinity, image is at focus. When the object is at focus, image is at infinity. So you can also remember like this, that as you're going away from the mirror, as the position of object is going away from the mirror or it is coming towards the mirror, the image is going far away. So it is basically, we can say inverse relation. Only one situation is different where we are getting the virtual image. So concave mirror is the mirror where we can get both real as well as inverted images, both enlarged as well as diminished image, as well as the same size image also. So if this is the table given in your textbook, this table you all should draw and put it on the wall where it is visible to all of you. This will become very helpful for your exams also. Now, this was about the formation of images by concave mirror. Let's have look at one of the question and let's see if we can solve it. So the question is from your textbook only. It says, it's from page 185. It says the image formed by concave mirror is observed to be virtual, erect, and larger than the object. So virtual, erect. So I just now told you in concave mirror, there is only one situation where we get the virtual image. Where should be the position of object? So which is that position? I guess we have, yes, you have guessed it correctly. The position is between pole and principal focus. So that is the only situation where we get the virtual image. Let's have a look at the answer also. Yes, you guessed the answer correctly. Option D, between the pole and principal focus of the mirror. This was all about part 5 of the video where we've discussed about the formation of images by concave mirror. In the next video, we'll talk about the rules for formation of images by convex mirror. In the meantime, do go through the video, and if you have any question, do put it in the comment box. That's it from my